Hi everybody, welcome to this special edition at Learnable Math, and it's on trigonometry. Okay, it seems like we have a lot of special editions on trigonometry. It's quite a very interesting section really. I know it's been quite some time without uploading, guys, okay, but here we are back at it again. Quite interesting times. Okay, YouTube said about 70% of you guys haven't subscribed. So if you're new to the channel, if you are returning, make sure that you have subscribed. Just turn on that notification bell, so that you can be notified every time when we drop. Okay, so our special edition is on trigonometry, and this is the interesting question that we're going to look at. Without wasting any time, let's get into it. All right, it says consider the trigonometric expression 16 sine x times cos exponent 3x minus 8 sine x cos x. Rewrite the expression as a single trigonometric expression, right? And find the values of x in the interval 0 to 90 degrees where the expression has its minimum value. Okay, so the first step is for us to rewrite this expression as a single trigonometric ratio, right? So obviously to do that, I'm just gonna rewrite it 16 sine x cos exponent 3x minus 8 sine x cos x. Just by looking at this expression like this, you can agree with me that we have sine x cos x here, sine x cos x there, right? And we have 16, we have 8, okay, which are factors. So you can see that we have a common factor. We can take out a common factor of 8 sine x cos x, right? If I take 8 sine x cos x, I'll be left with what? To get this one, I'll be left with 2, because 8 times 2 will give us 16, right? Then sine x is gone. Then cos 3x divided by cos x will be left with cos squared x. Okay, then minus what? Minus 1, because we have taken the whole of that. So to get something in brackets, it's like you are dividing by your factor, so it will give you 1 there. Okay, so you can see we are heading somewhere. We do recognize that this, it's actually a double angle of what? Of cos, right? So 8 sine x cos x, I can see a rule inside there. This is double angle of cos, which is cos 2x. All right, so you can also see some vibes of double angle of sine there, right? Remember, if you have sine 2x is the same as 2 sine x times cos x. Okay, so if I rewrite it like that, I'll have 4 outside, right? 4 times 2 is the same as 8, right? 4 times 2 is 8. Then I have sine x cos x, so that you can clearly see what I'm talking about, right? So you can see this portion, 2 sine x cos x, it will give you what? So the 4 is outside there. 2 sine x cos x is actually double angle of sine, which is sine 2x. And this is being multiplied by cos what? Cos 2x. So you have 4 sine 2x cos 2x. Okay, can you see another double angle of sine here? Because we have sine 2x cos 2x, right? So again there, if I take out, I can write it as 2 times 2 sine 2x cos 2x, so that you can see that this is still double angle of sine, right? So it will be 2, this 2 outside here, then that thing there will give us sine 2 of, we double the angle, right? You have to double the angle of 2x, so this will be 2 sine 4x, and we have successfully written it as a single trigonometric expression, right? Then it says we have to find the values of x in the interval 0 to 90 degrees where this expression has its minimum value. Okay, let me just delete some things here to create space. Now we are looking at a simplified expression 2 sine 4x and we are asking ourselves, what are the values of x that are within the interval 0 and 90 where this expression has its minimum value, right? So obviously minimum value, it's when this expression is actually equals to a minimum value, right? It's minimum value. Okay, so I've already showed you, if you check our session on special edition of trig, I think it was of trig, where I showed you how to get a minimum value of any trigonometric function, right? So if you have a trigonometric function, this form of a sine x plus q, then to get the maximum value you just say amplitude plus q. To get the minimum value you just say negative amplitude plus q. All right, so that's the idea. So in this case we must identify what is our a, what is our q. Q is the vertical shift, right, and a is the amplitude. So in this case our a, you can see anything multiplying your trigonometric expression, so that is 2, right? A is 2. Obviously you don't have the vertical shift there, so q is 0, right? So the minimum value, it will be minus amplitude plus q, which will be minus 2 plus 0. Obviously it has its minimum when it's equals to negative 2. Okay, so what we're gonna do, we're gonna say 2 sine 4x must be equals to what? Negative 2. And we can now solve those x values where this function is at its minimum. Okay, so that's what we're gonna do there. Let me just delete to create some space here. Okay, so at this point we can solve for x by dividing both sides by 2. So these two cancel this and this. Then you have your sine 4x is equals to negative 1, right? Then you can start solving for x. 4x is equals to the arc sine of what? Of negative 1. Okay, you can perhaps apply the idea of a general solution so that you can get all those x values that are within that interval, right? So what I can do at this point, I can rather go and find my what's this, they call it critical angle. Is it a critical angle? I think that's how it's called. But other than that, I can just say 4x equals to arc sine of minus 1 and punch a calculator, right, and see how many I will get. Okay, so this one worked for me. What I'm gonna do is I'm just gonna find a reference angle, right? So I'm saying reference angle, so I'll say 4x is equals to arc sine of positive 1, right? Because the reference angle must be positive, then it's giving me 90 degrees as the reference angle. Then what I do is I go on the quadrant where this is negative, right? Sine is negative on the third quadrant and also on the fourth quadrant. Okay, the third quadrant is defined as 180 plus theta. Fourth quadrant is defined by 360 minus theta. Okay, so I'll say 4x is equals to 180. My theta is like a reference angle, right? Reference angle. Let me say reference angle. So I'll say 180 plus the reference angle, which is 90. And I'll say 4x is equals to 360 minus the reference angle, which is 90. Okay. So this will be like 4x equals to what? 270 degrees divided by 4, divide by 4. Then you can solve for x. X is equals to 270 divided by 4, which will give you 67.5 degrees. Okay, and you can see it between the interval 0 and 90. Then at this point, 360 minus 90, again, this side you are getting 270, right? So if you divide by 4 like that, you'll get x equals to 67.5. Is this the only x value? No, we can go and get more, right? We can go and get more by just writing that in its general formula to say 4x is equals to it was equals to 270 degrees plus k times 360, which is the period of sine, and we saw x equals to 67.5 degrees plus k times, so 360 will also be divided by 4, right? As you divide by 4 there, 360 divided by 4 will be 90. Okay, so what you can do is, when there is k, you can go and substitute k is equals to minus 3, minus 2, minus 1, 0, 1, 2, and 3, right? And check what are the values of x that will be within that interval. So when k is equals to negative 1, it's gonna be negative. So this one for negative won't work. When k is 0, it's just gonna give you 67.5. When k is 1, it's gonna be above because it's 67.5 plus 1 times 90, which will be 157.5, which is above the interval. So the correct answer for our case is 67.5 degrees. All right, I hope you find this helpful. Don't forget to like, share, comment, and subscribe. See you soon. Bye.